Alright, so now it's number SO5. Yeah. They said he wasn't good enough for SO. Oh.
SOS.
There's some kind of title of some video.
And then you solve SO5 in 10 minutes.
No. Solve it in negative 10
And doing
don't
this
solve
stretch.
it.
The stretch.
Don't solve it in 10 minutes.
Oh.
Solve it.
That's okay. Alright. 1, 2, 3, 4. Okay. Oh wait, I don't need colors. Oh, I don't need colors. Oh, whatever. Okay, so we have two chessboards. This one is 50 by 100, and this one is 100 by 100. Okay, and we have two people. One for, what are the names? This one is Petia, and this one is Vasia. Yeah, okay, and both of them are trying to place 500 kings. 500 kings on each of the chessboards. And the condition is, for Petia, none of the kings can attack each other. So they can't like stand adjacent to each other. And for Vasia, it's the same, except they can only place it on white squares. Okay? Right. So the question is, who has more ways to place their kings? Okay, so what we want to do first, we're going to define a function from this chessboard to this chessboard. So consider some row, some column, this one. Yeah, it's 50. And it's gonna go. So since they have the same number of columns, right? They both have 100 columns. This, like each column is gonna go to the same column. So if this is like the ith column, yeah, it goes to the ith column next one. But this one has 100. So what we do is we stretch it, right? So okay, so some of these are black, some of these are white. So each square from here will go to a white square. This will go to the next white square, and to the next white square, the next white square, and so on. Yeah, and since half of these are white, that means 50 of them are white, and there are 50 here, so it works out very nicely. Okay, so after we stretch it, right, all the kings they stay on the same square. So what we want to prove is that if a position exists that Petia has placed, after we stretch it, it still works as one of Vasia's combinations as well. Okay, so let's just say we have some kings here. Okay, so we're gonna have like, let's just consider two kings here and here. Okay. Okay. So if the two kings are like difference are more than 2 columns, after we stretch it, since it stays in the same column, there's no way they can attack each other, right? Because they're staying in the same column. If the columns are this far apart, they're going to stay that far apart, so they're not going to attack each other. So we don't have to consider that. Now, if they're in the same column, right? We're stretching it so they get further apart, so they're still not going to be attacking each other. Yes. So now we have to consider. Right. We have to consider if they're in adjacent columns. So it looks like this, which is a bit more dodgy, but surely we can do this rigorously. All right. Okay. The thing is, the hard thing about this is because you don't stretch each column by in the same way, because some of the 100 ones they start out as white, and so it's kind of different. But this is fine, right? So our function is for like, say this is 1, 2, 3 all the way to 50. Yeah, we're taking k to 2k if we're going from here to here. Yeah, if we go from here to here, it's going from k to 2k minus 1. Yeah. So for these two squares here, say this is in position I and J. Once we stretch it, this will be. There are two cases, right? This could be 2I and. Oh, okay. Well, this one is I plus 2, right? Because it's 2 above. Yeah. Okay. And then this is 2I plus 2 minus 1, or it's 2I minus I minus 1 and 2 times I plus 2. Okay, so we just have to check these aren't very close to each other. So this equals 2I and this is 2I plus 3. So obviously they're too far apart. And this one is like 2I minus 1 and 2I plus 4, which is even further apart. Yeah, so they're never adjacent to each other. Okay. Yeah, so that basically proves if there's like a configuration of kings on this one, and after we stretch it, none of the kings attack each other still, which means it still works as a configuration here. Because also, yeah, all of them go to white squares, which is the other condition. So yeah, it works out. Now we want to prove the number in bus here is bigger. Yeah. So they can't just be equal. It can't be like 1 to 1. So we're gonna construct a case here where if we put it in the function backwards, it doesn't work anymore. Alright, so all the ones that work here get transported over here. But since this is larger, there has to be something here that doesn't work back here.
So you're defining a function that's injective, projective.
Yeah, basically. So we're just gonna do construction, okay? We're gonna color every like second one. Up here, dot dot dot. How many is that? 50? And we do that for like 10 of the rows. Dot dot dot.
Yeah, this part's fairly true.
Dot, dot, dot. So like that's 50 in each row, 50, and then for like 10 of the rows. Okay. So obviously it works here, right? None of them are attacking each other. They're all different of 2. But after we reverse stretch it, we squish it back to 50, it ends up looking like this. Dot, dot, dot. So obviously they attack each other here, so it doesn't work. So that means bus here has more combinations than text here. Yes. Thank you.
No, thank you.
Questions?
How
do I get zapped every time I touch anything?
What?
Oh, there's a clapping cool thing.
Oh.